Hi, everyone, and welcome back to math. It's been a while since we've done one of these lessons together, but this is our final unit. It is Unit 12, and it is titled Tessellations. So in this unit, we're going to be exploring what a tessellation is and what different types of polygons are, etc. So the first lesson will be somewhat of a review, but you still need to know it for the remainder of the unit. You definitely do. Now, so you're going to figure out that what a polygon is and why. Now, polygons are closed plane figures that are made up of line segments. Now, if you don't remember what a line segment is, a line segment is a piece of a line. That is a line segment. Not a line, it is a segment because a line, by theory, is infinity. It goes on forever and ever and ever. So any line that begins and ends, as such, would be considered a line segment. So now, a polygon, again, is a closed plane figure, meaning all sides are connected to make a closed plane or some sort of shape that connect. And they're all straight and not curved. Next lesson, we're going to get into the difference between regular and irregular polygons, but for the purpose of this lesson, we're simply looking at polygons. Now, which ones are polygons? Now, this one is, oh, does that even work? This one is not. Oh, that's loud, because it is not a closed plane. You can see right here, it is not closed. This one is not. That plane is not closed. Theoretically, this one would be yes, and the rest of them would be as well because they're all made up of line segments that close that plane off. So therefore, by definition, they are polygons. Now, a three-sided polygon, they're called triangles. Now we're going to go over the different types of polygons. Now, triangles have three sides, okay? Again, my daughters were learning this in grade 2, so this should not be that difficult for you guys. Now, I'm not going to go through the whole thing and say which are the triangles, which aren't. You should know that the ones with three sides are triangles, okay? The ones not with three sides are not triangles. Now we moved on to our four-sided figures. Now, these are called quadrilaterals. Now, there are various types of quadrilaterals. You can see here, this one is a rhombus right there. Oops, I didn't write that. So this one, the types of quadrilaterals or four-sided figures, this is a rhombus. Okay, it is like a diamond, but where two sides are longer than the others right there. We have a square right there. We have a rectangle. Right here, this is called a parallelogram. It's kind of a slanted one, but the adjacent sides here are the exact same distance or the exact same length. Okay. And it is a slanted four-sided figure called a parallelogram. Another one would also be a simple diamond. Now I've listed four types. We have rectangle, rhombus, diamond, square, and parallelogram. Those are the types of quadrilaterals or four-sided figures. Moving on to this, we have five-sided figures, which are pentagons. All you have to do is count the number of sides right here. These are the faces of the figure. Okay, so you count the faces to determine the sides. You do not count these things right here, the corners. Just a reminder, those corners, as in grade 7, though each corner is called a vertex. That is where two line segments meet. If you have multiple corners, they're called vertices. Vertices. So I would say, to be grammatically correct, can't do this right now. ICES. To be grammatically correct, I would say this would be a parallel, not even. This would be a square or an irregular an irregular polygon. But I would say that this has four vertices, and I would say this is a vertex right here. So again, five-sided figure. You count the faces. That has five sides. This one does not. This one we're looking at 1, 2, 3, 4, 5. So by definition of pentagon and polygon, which we have thus far, this would be a five-sided figure because it has five faces. Okay, moving on to hexagons. Hexagons are our six-sided figures. So hexagons have six-sided. They are polygons with six faces, not six vertices. We're looking at 1, 2, 3, 4, 5, 6. So therefore, this one would indeed be a hexagon. If you're looking at this one, 1, 2, 3, 4, 5, 6. Hexagon. How about this guy here? 1, 2, 3, 4, 5, 6. Hexagon. Okay. 1, 2, 3, 4, 5, 6. Hexagon. Again, these are figures with six faces. Now, a seven-sided figure, seven-sided polygon, would be called a, well, we don't have it on here for whatever reason, so I will add it in here. Seven sides is called a heptagon. Heptagon. That is a seven-sided figure. All right. We go back to the eight-sided figure, which you guys should know based on, think of an octopus, 8 tentacles, eight-sided figure, octagons. That root word octa means 8. Okay. Stop signs, octagons. There you go. But we're not going to count them all, but you could probably look at this one right here and just tell that it is, or this one particularly, tell that it is. This one, to me, it doesn't look like it has 8 sides. Apparently it does. Anyway, so again, 8 faces, not vertices. We're going to move on. We're going to go to this one right here. I want to tell you guys a couple of more polygons that would be good to know. 9 is called a nonagon. Oops, a 9 is called a nonagon. Nonagon. A 10-sided figure, which you guys should know, is called a decagon. And for fun, let's go a 20-sided figure is called a isosagon. There you go, EU questions for your exam. Okay. All right, what we're going to do now is we're going to break down polygons into 2 specific subcategories. There are regular polygons and irregular polygons. What you need to know about regular polygons in general are a couple of things. 1, they're all made up of line segments. Number 2, any polygon, by definition, may not have a curved angle. Okay, there may not be any curves or circular type angles, or not angles, circular type line segments in them. And also, all polygons' interior angles. So when you add up all of the angles of the interior of a polygon, they must equal 360 degrees. We know this one is a square, okay? And each corner of a square is 90 degrees, okay? When you add all of those up, that should equal 360 degrees. So therefore, this is a polygon. We know that this is a polygon because it has the characteristics which we talked about. It has line segments. The interior angles equal up to 360 degrees. It is a closed plane figure. Now, we know it's a polygon because of that. We've determined that. However, we don't know if this is regular or irregular. Now, there's a fundamental difference between regular and irregular polygons. That being, the regular polygon has equilateral sides, meaning the opposing sides of that polygon are the exact same length right here. They're identical, so the opposing sides of these two are the exact same length from one length, so this and this. And this side and this side are also the exact same length. So they're equilateral, and not only are they equilateral, all opposing angles are equiangular. So this angle and this angle are the exact same. This angle and this angle are the exact same. So we can determine that this is indeed a polygon because it is made of line segments. All of the angles, when you add them up, we know it's 90 degrees, so therefore it equals 360 degrees. It's a closed plane figure, so we know it's a polygon. Then we look to further categorize it to regular and irregular. We look at these opposing sides are equilateral. Therefore, they are the exact, meaning they're the exact same length, the opposing sides, and the opposing angles here and here are both equiangular. So therefore, this is not only a polygon, it is a regular polygon. So we can move that guy on up to the regular polygons category. Similar, this square, as we determined, it is a polygon. It's a closed plane figure. It's made up of line segments. All angles, when added up, equal 360 degrees. Therefore, it is a polygon. We also look, the opposing sides are equilateral, meaning the same length, and the opposing angles are equiangular, meaning they're the same angle, and therefore this would be a regular polygon as well. If we look at this parallelogram here, you can tell that the opposing sides are equiangular right here. These are equiangular, and these opposing angles, you can't tell with 100% certainty without measuring, but you can be fairly certain by looking that they're equiangular. You know it's made of line segments, so it is a polygon, and based on our information, this would be a regular polygon. You look at this. Are there curved sides? Yes, therefore it is not a polygon. This one here, okay? We know, based on our definition, if you were to add up these angles, they would equal 360 degrees. It's a closed plane figure made of line segments, so therefore it's a polygon. But if you look at the opposing sides, you're to look at this side right here and this side right here. I'm not 100% certain, but they may be equilateral in the same size, but we know this side is, and this side, they're not equilateral. Therefore, the angles wouldn't be the same, so it's a polygon, but it would be an irregular polygon. Okay, this one, you can tell a triangle, equilateral, equiangular, closed plane figure equals 360, regular polygon. This one here, you can actually see that the plane, what about this one is, if these were connected, you could conclude that this is likely a irregular polygon, but they're not connected. So therefore, that is a non-polygon because they're not connected. It is not a closed plane. Another parallelogram, regular. Octagon, or this one, regular. Regular. And this one here would be in, I don't know, based on the looks of it, probably regular. This would be irregular. This one would be a, well, we don't know. This is two triangles, so I'm not sure what to classify that one as, but these ones have curved figures. Therefore, they would be non-polygons. I hope that's making sense to you guys. Now, your assignment is not to do the get ready, but I will grab that assignment for you once I find it, so just hold tight. Okay, I'm back. I've decided that based on the fact that it is a 4-day week next week, we are not going to have an assignment that accompanies this, but we'll have one assignment this week, and that will be in the next lesson on tessellations.